Okay, in this presentation we're going to look at compound Poisson distributions. They turn up quite a lot in financial maths and mathematics to do with insurance and actuarial studies and so on. So expect them. They should come up. And you should recognize one when you see it. Okay, so you're not told anything about compound Poisson distribution here, but you are given enough details. So let n be the number of claims arising from a group of policies in a period of 1 week, and suppose that n follows a Poisson distribution of mean 60. Poisson distribution means 60. Just as a remark, that means the variance is 60 also. Okay, let x1, x2, x3 all the way up to xn be the corresponding amount of claims. Okay, so it can vary from week to week. Sometimes we might have 60, sometimes we might have 55. Sometimes we might have 65 and so on. So it varies from week to week. Be the corresponding claim amount, and suppose that independently of n, these are independently and identically distributed, mean of 500 and standard deviation 400. Let S be the summation of all these. So let's just pick some numbers here. Let's say 450 plus 525 plus 670, yeah, whatever it is. Okay, so it should add up to a 5-figure sum of some description, okay, for each given week. Let's just say here it's 25,725. That's just one particular week. Just making up numbers there. That's with more to come. So let that be the total amount for 1 week, okay? Again, just to be clear, that means the first 3 of a whole sequence of them. So determine the mean and standard deviation of S. Explain why the distribution of S can be taken to be normally distributed or approximately normally distributed, and calculate approximately the probability that S is greater than $40,000. So just actually, you sort of see the key word here, approximately. That just sort of says hints us to go in a particular direction. The normal approximation, which usually sort of entails the central limit theorem. So that just drops a hint there. So first off, it doesn't actually state that it's a compound Poisson distribution, but it asks us for the mean and standard deviation. Now, in this particular video, I'm just going to get straight to the point. So you should actually know that this sort of follows this description, that it's a compound Poisson distribution. You just actually might have to sort of state it explicitly. This is a compound Poisson distribution. S is a compound Poisson distribution, okay? Now, that's S is compound Poisson. N is Poisson. And the expected value and variance of the compound, when n is Poisson, the expected value and the variance of the compound distribution. Here we're using y just as general notation, but I'll just change it to S just to sort of stay consistent with what we're doing. Now, in this video, as far as we're concerned, we'll take it as read that these definitions you're allowed to just give them. Okay. In other presentations, I actually go into more detail as to how they come about. Okay. Law of total variance and law of total expectation and so on. So, as far as we're concerned for this video, we can use these automatically. Okay. Now, just as a remark, the variance of x and the the variance. Yeah, that's everything we have there. Actually, that's everything we need. So the expected value of S is the expected value of N times the expected value of X, which is 60 claims on average per week, and each claim is on average $500. So that means $35,000. Now, the variance of S is a bit more work involved. Okay. Just as a remark, actually, I just realized here that I could have used the variance of N is the expected value of N, okay? That's how we can use that there. I'll just sort of stick with where it is, actually. I just sort of use this definition here, just to sort of stick where we are, okay? I've done these at 2 different times. So it's 600 times the variance of X, which is 400 squared. So 60 times 400 squared plus 60 times 500 squared, 24,600,000. When we get the standard deviation of that, it's just shy of $5,000 US, 4,960. Okay, so that's the standard deviation there. Okay, the variance correctly would be denominated in dollars squared. Just feels weird. It's correct, but it just feels weird. So those are the two answers we're looking for. And remember, it's just to sort of spell them out explicitly. Okay. Good. Now, the rest of it is as follows. It's a short enough part of it for the rest of it. Essentially, what we're going to sort of state here is that S is sum of a large number of IID, identically and independently distributed variables. The central limit here gives an approximate normal distribution for S. Okay? So this is just really a bit of theory here, but just remember to spell out something like that. I know in exam time situations you're under pressure, but just give a full answer like that. Drop in the IID, mention that, mention the central limit theorem, approximate, normal, all those little keywords just add up to full marks, okay? But I do recognize in an exam situation that it is pressure can be on. Now, so essentially what we're asked here in the last part is, what is the last part? I've forgotten actually. Let's just go back up here. Calculate the probability that S is greater than $40,000. Essentially, this turns into a Z-score type calculation. Here we're using the fact that mu and sigma are here. So that is, it's not there actually. It is down here. And that's here. Okay. So it's a Z-score calculation. Okay. So really, if you're doing one of these right now, you should be fairly okay with this. Okay, I just realized a little missed the brackets there. So your Z-score should be 2.016. Okay, get as close as you can to that, 2.01 or 2.02. You should end up with an answer of 0.0219, something like that, around 2% approximately. Okay, give or take. Should be have an answer closer to that. Again, in these sorts of situations, rounding error is expected, but just show your workings very clearly. Okay, there's a number of different ways you do Z-score. Some people use statistical tables. Some people will be using computers, and they get to give more accurate answers. Just try your best. We should get an answer of close to a Z-score of 2.016, something close to that. And your probability should come out to be approximately 2.2%. So we'll leave it there.